Welcome to Amazon Web Services Programming with Delphi CodeRage X session. My name is Paweł Głowacki. I'm working for Embarcadero as EMEA Technical Lead for Developer Tools. And today I'm going to talk about cloud computing, especially in the context of using cloud computing from Amazon Web Services and using RAD Studio 10 Seattle release to integrate applications with different Amazon services. I'm going to focus on Cloud API, the interface that RAD Studio provides that supports three different Amazon Web Services: simple storage service for storing arbitrary unstructured data, for SimpleDB or simple database service, and also simple queue service. Then I'm going to move into the understanding of the Cloud API architecture, and we are going to see what it takes to extend Cloud API on the example of integrating with a simple notification service. So, what is cloud computing? Cloud computing refers to the on-demand delivery of IT resources and applications via the internet with pay-as-you-go pricing. Whether you are running applications that share photos to millions of mobile users or you're supporting the critical operations of your business, the cloud provides rapid access to flexible and low-cost IT resources. With cloud computing, you don't need to make large upfront investments in hardware and spend a lot of time on the heavy lifting of managing that hardware. Instead, you can provision exactly the right type and size of computing resources you need to power your newest bright idea or operate your IT department. You can access as many resources as you need, almost instantly, and only pay for what you use. Cloud computing provides a simple way to access servers, storage, databases, and broad set of application services over the internet. Cloud computing providers such as Amazon Web Services own and maintain data centers across the globe with the network-connected hardware required for these application services, while you provision and use what you need via a web application. You can think of the cloud as a large-scale, publicly accessible collection of compute, storage, and networking resources. These are allocated via web service calls using HTTP protocol and are available for short or long-term use in exchange for payment based on actual resources consumed. In other words, it is a programmable data center that your application can integrate with. Amazon Web Services are hosted in multiple locations worldwide. These locations are composed of regions and availability zones. Each region is a separate geographic area. Each region has multiple isolated locations known as availability zones. Amazon Web Services provides you the ability to place resources such as instances and data in multiple locations to achieve better latency, scalability, and redundancy. So it's more than just an app. If you look at this picture, you can see that solutions that you can create with Amazon Web Services and application development tools such as RAD Studio, you can build complex end-to-end solutions that are made of a number of different components. This particular slide, you can see a screenshot from the Amazon Architecture Center, when you can see an example of a web hosting scalable web application with different tiers, with web servers, with load balancers, with application servers that scale on demand, and with databases at the backend. It's very much like building your new solution with Lego bricks. So let's start looking at some of the web services that are supported by a Cloud API. So before we can actually start using them, we need to understand some basic concepts. So we're going to specifically talk about first identity and access management. So identity and access management service you can grant other people permission to administer and use resources in your AWS account without having to share your password or access key. For example, you can grant different permissions to different people for different resources. For example, you might allow some users complete access to Amazon Elastic Cloud Compute or Amazon Simple Storage Service, but for other users, you might allow read-only access to just some simple storage buckets, or permission to administer just some EC2 instances, or maybe access your billing information but nothing else. That's quite critical service. You don't want to use your master key and master account name, your master password with EAM. You can generate those credentials to be used inside of your applications. Another service that we are going to use today is Simple Storage Service. It's one of the historically first services created by Amazon, and in fact is one of the most commonly used services. You might not be aware that your applications are using Simple Storage Service. If you are using Dropbox or you're using Netflix, you are actually using Simple Storage Service. Those applications are just layers on top of the Simple Storage Service. With Simple Storage Service, there are actually almost no limits on the number of data that you can redundantly store. You can create objects of the size up to 5 terabytes, and they are organized in a bucket. You can have up to 100 buckets, but within buckets you can create folders that create a folder like directory structure that you can organize your objects. But within a certain bucket, there are clearly no limits on the number or size of objects that you can store. So then, when you have your bucket created, the next action is to upload objects to your buckets. You can download those objects later to your application, and also you can set access controls, so those objects might be private to you, or maybe they are accessible publicly through the URL. If you think about for example, NASA and the Mars Curiosity rover, it's a great example when this clever device is sending to our planet Earth hundreds and thousands of high definition images, and they are all stored inside of the Simple Storage Service. So this is a very powerful alternative to a traditional database. Maybe you don't need to store your data in a SQL tables. You just want to store some number of bytes. Another interesting service that is supported through RAD Studio is Simple Database Service. It's an example of a non-relational data store, something nowadays called NoSQL databases, where you have domains that are very similar to database tables, and they contain items or rows that are kind of similar to database table rows, but then we can have a number of attributes that belong to items. What is different from a traditional database is every single item can have different attributes, so you don't create a database metadata up front, but you can add and modify the structure of your data as you go. The difference as compared to a traditional database is that you cannot create queries that span multiple domains. You can query only single domain using a SQL-like language. Another interesting service that you can access from your RAD Studio applications is Simple Queue Service. Simple Queue Service is an interesting service where you can decouple the components of an application so they can run independently. And with Amazon SQS, you can make it easy to exchange messages between those components. Any component of a distributed application can store messages in a fail-safe queue. Messages can contain up to 256 kilobytes of text in any format. Any component can later retrieve the message programmatically using the Amazon Simple Queue Service API. The queue acts as a buffer between the component producing and saving data and the component receiving the data for processing. This means that queue resolves issues that arise if the producer is producing work faster than the consumer can process it, or if the producer or consumer are only intermittently connected to the network. So Amazon's SQS ensures delivery of each message at least once and supports multiple readers and writers interacting with the same queue. A single queue can be simultaneously accessed by many distributed application components with no need for those components to coordinate with each other to share the queue. So this is very powerful of creating applications that can process a lot of data, where you want to make sure that your data is processed regardless of the number of data to be processed. So these are the three main services that we are going to focus, and these services are supposed by Cloud API, which is an API inside of RAD Studio, available to both Delphi and C++ builder applications. And this API not only works with Amazon Web Services, but they also work with Windows Azure. So Cloud API provides certain abstractions to work with storage, so storing arbitrary amounts of bytes, table, so working with a non-SQL table-like data, and also queues. So for both of these services, Microsoft and Amazon, you have different classes that represents those services and make it possible to interact with them programmatically. So there are actually 3 units inside of RAD Studio that provides the Cloud API interface. There is one inside of the unit data.cloud.cloud API. There are some base, abstract, common classes that all specific vendor supports. And then inside of the data.cloud.amazon API and data.cloud Azure API, we have implementation specific classes that are wrapping access to a certain interface. So how do we start? If you create a new application, this could be either a multi-device application or maybe Windows VCL application. In the tool palette you will find the cloud category, and there are 2 components. One is Azure connection info and the second one is Amazon connection info. So these components are a starting point for accessing cloud services. When you want to start using cloud services, you need to create an account or on a given platform. So you need to log into the aws.amazon.com and create your account, and then you will be given your account key and account name. But we already know that you want to go into the identity and access management service to generate your specific key and name to be used inside of your application with certain restrictions that are specific to your application. The next step is actually to instantiate one of the service classes that you want to interact with. So there are 3 different classes. If you want to work with a simple storage service, you need to create an instance of a T-Amazon storage service. So constructors of these classes, the Amazon Table Service, the Amazon Queue Service, accepts as a parameter a connection info. So after constructing an instance of these classes, you can start calling methods of these classes that result in issuing an HTTP request to the cloud service, and then they return results and information about whether your call was successful or not, and some data that you can actually make use inside of your application. Okay, so I think it's a good moment to create a first demo. So I'm going to create a image master multi-device application that is going to use Amazon Simple Storage Service for storing images taken with a mobile device, and then we are going to keep track of these images in a SimpleDB database. So our application is going to interact with these two different Amazon web services. Okay, first let's have a look at the Amazon Web Services Management Console. This is a web page where you can access your resources, different services. After you log in into the Management Console, you can select one of the regions that you can work with. So it is quite important, because if you select a different region, you won't see the resources that are in other regions. So if I'm currently using the EU Ireland region, and if I create some entities there, like for example virtual servers or some other resources, that they won't be visible if I would, for example, select EU Frankfurt. So I'm currently going to use EU Ireland. In fact, in case of the first service that we are going to use, the Simple Storage Service, if you go into the Simple Storage Service, you can see that this is actually global. So the Simple Storage Service does not require region selection. However, later we are going to see that it's not necessarily the case, because when you try to access the service programmatically, you will need to specify a certain region for some reason, and I'm not sure why, but this is the case. Here you can see different buckets. So we have a create bucket option, and you see I have different buckets created here. I can create a new bucket. I can specify where I want to have it, and what is important, bucket name cannot contain spaces and has to be globally unique. So this is my super unique bucket. Okay, create. Okay, so now I can actually, inside of the bucket, I can take and upload arbitrary files. I can select files. For example, I can go into the pictures, I can select a file of a picture, and I can upload it. So this is something that I can do interactively using Web Console. I can also make this file available publicly. By default they are private to me, and then each of the files that you upload to a Simple Storage Service, it will have its own URL that you can also use to directly download the file without using any APIs. Just provide this particular link, and you can just download the file locally. So this is something I'm using also when I want to share with my friends some big files that does not fit into the email as an attachment. So it's a great thing on its own. Okay, so let's go into the RAD Studio. Here I have a multi-device application. So this application demonstrates how you can integrate with the Simple Storage Service and the Simple Device Service. So let's have a look what this application does. So I can compile this multi-device application as a Windows application, but this could be also compiled as an application for Android or iOS from the very same source code. If I click on it, I can select an image that could be taken. In the case of the mobile application, could be taken with a camera, but in case of a desktop application, I have an open dialog, and I can click on upload photo, and this will actually upload the photo to Simple Storage Service and also upload a record to a table inside of the SimpleDB service. So here I have a list. If I click on refresh, I can actually see my photos. If I go back and click on a different one, I have a image of a fish, or if I click on a different one, I have another chrysanthemum. So that's the functionality of my application. Let's have a look at the source code. So first of all, I have a data module with an Amazon connection info component. So this connection info component contains two properties: account key and account name. So this is quite critical that you have this properly configured. If you go to the services, you can see there is an in the category of security and identity, we have the identity and access management. Here I can create users. So I have created a Paweł storage user. So you create a new user, and then you can grant a specific permission to this user. So you can, for example, specify that you only want this user to access a certain resource. In my case, this user has an access only to the Paweł storage bucket, and it can perform different actions using the simple storage service. So in reality, my real user in this application is more privileged, because I want to also access SimpleDB service. But that's the when you create a new user, you will get a access key, and this key needs to be used inside of the account key and account name properties for accessing a simple storage service. Another thing that actually I spent quite some time actually trying to understand why it is not working. So before Delphi 10, in Delphi 10 and in C++ Builder 10, there were some improvements. So first of all, the underlying classes that are making HTTP calls are not longer based on the INDI. So they are based on the new net client that is actually integrated with the native HTTP client functionality on each supported platforms. And if you want to make this Amazon connection info to work, you need to specify use default endpoints to false, and then you need to specify this endpoint. By default, that will be only s3 amazon aws.com, but for some reason, if you do it like this, your calls will be unsuccessful. You need to use it in this way. Okay, so this is my Amazon connection info. I have wrapped it in a make it accessible through a function get default connection info, and this is what I need to instantiate instance of a service. So here I have a data module. So this is my data module DM-S3 that wraps the functionality provided by the S3 service. So I have also created a little config class that gives me a name to my get default S3 bucket. So this returns Paweł storage. So my credentials are actually configured to work with this particular storage. So I want to have it hard coded in my application, but in a central location. So that's why I have this class tconfig that gives me this information. So then I have a T Amazon storage service class that is a member of my data module, and also you want to add to the users clause the Cloud API and Amazon API units, where all the Cloud API classes are defined, including this Amazon storage service. Here I'm going to have a lazy creation pattern. So instead of accessing my FS3 directly, I have a property with a getter, and this getter actually before returning a reference to FS3, it checks if the FS3 is not nil, and if it's nil, then it will instantiate my T Amazon storage service. So this is a common pattern in the Cloud API where you call a constructor of a class and you provide a connection info component that is used to instantiate your class. So in this way, and it's also good practice in especially mobile applications, you don't want to create all the classes at the startup of your application. The very moment I start accessing this functionality, it will be only then created. And how I work further. So I have two methods, one that is uploading a bitmap and one is downloading a bitmap. So my S3 class provides a functionality to upload an object. You can actually see inside of the source code. So the nice thing with RAD Studio that all the source code is provided, and all these methods are very nicely documented, so you can see it for yourself how this is working. So I have a method to upload an object, and this method accepts a bucket name, so where I want to upload my bitmap object name, so every object needs to have a unique name. And the third parameter is the actual content, so this is just a array of bytes, so this could be anything. So in my case, my method accepts a bitmap and it creates a byte stream, saves a bitmap to the byte stream, and then I'm just uploading the array of bytes of my byte stream, and then I'm actually done. So if this is successful, that's what I'm returning from my method. So basically, if the call to upload object was successful, I'm returning the actual name of the object that was generated. And I have here another class identifier generator that gives me a new ID. So this is something I can see. Basically, it takes a current date and time and creates a nicely formatted string out of it. So that's the functionality. And downloading the bitmap is very much the same. You need to just create a memory stream. You call a method getObject. You specify the target, the bucket name, the object name, and you need to provide a reference to the memory stream that will be used to hold the returned bytes. So if this is successful, that I'm creating an instance of a tBitmap and I'm loading all the bytes into a bitmap. So that's a functionality of my simple storage service wrapper. The functionality of my SimpleDB wrapper is different. I have the same structure where I have a lazy creation of my SimpleDB reference. So there is a method here, SimpleDB, that actually returns a SimpleDB reference. If it's nil, then it's constructed based on the connection info. And here with SimpleDB, we need to there are two methods. One is to insert information about the image, so just inserting the image name, and the second method is to return the list of all the objects that are actually stored in S3. So first, let's have a look at the insert image info. So it's not very complicated. I have my tconfig that stores the hard-coded name of my table, and this table has only one attribute or one field, if you like. So this is my in my config. I have the cloud images is name of the table, and the S3 object name is the name of the attribute. And that when I create a new row or new record, it has to be uniquely identified. So again, I'm reusing my class for generating identifiers. So the table, the method that basically invoke the HTTP request is insert row, and you need to first create a table row reference and add and set some columns, and this is what we pass to the insert row. So you specify the table name, a unique identifier, and the reference to a table row that contains one or more columns. After we are done with this reference, we want to make sure to get rid of a table row reference that was created because it's no longer necessary. And again, we have a success if everything was okay. In fact, I see here that we don't really check for a success. That should be probably a function that returns true or false. But let's keep it simple as it is. And then we have a next function that returns the list of all objects. So we have a reference to the string list that will contain the list of all the object names. And again, we want to have a table name and a column name that is hard-coded. We assume that the string list is not nilled, so we call clear on it, so it is empty. And then we need to create a get rows specifying a table name. This will give us a response list, and the response list is a generic list of tcloud table row references. And if it's not empty, then we can do a loop to go through all the rows and add the value of our column to the list of rows. And that's the whole functionality. So my form main is using this functionality. So if I want to upload a photo, I just take a photo. So first of all, this is a nice code here that if we want to take a photo on a mobile device, we have an action list and an action take photo from camera action, and this action has a method event on did finish taking, and this will give us a bitmap, and we assign this bitmap to this image that we want to send. And there is also a version for desktop applications. So if you click on the image, then we have a conditional define if it's Windows or Mac, and then we display a dialog to select image from the hard disk. So once we have an image that we want to upload in the image, then we can call it upload image, and then what we do, we basically take a bitmap and we call upload bitmap, and if this was successful, then we insert an information about an image. And then if you want to display a list of images, on the second tab we need to click on the refresh, and this will refresh an image list, and this is basically creating a string list, calling a begin update followed by the end update on a list view. We get a list of all the images, and then in the loop we are building the contents of the list. So that's and then if we click on the individual item in the list view, then we download an image, we put it in the image photo, and we switch the control tab to the active tab. So that's the whole functionality, and I think it's quite easy to follow. There is a very interesting demo that comes with installation of RAD Studio, and this is used for testing the functionality of all three supported services. So there is something here called account. So you need to create an account, and then if you run the application, and I have already created an account for my Amazon access. So here I can just start calling methods. So you can see Amazon tables. I can get tables. I need to specify the connection. Get tables. I don't want. It can be XML. Okay. So that's how it looks as a raw XML, or you can get it as just a list of tables. I have my cloud images table. I can take this table, put it into the test table, paste it, and then get rows. You can have it as an XML. So here you see these are my attributes. They have the same name, but the name of the image is different. That's what I'm using for downloading data. So this is very useful. You can also play with queues. So I can create a queue, I can get properties of a queue, I can also play with a simple storage service, so I can list my buckets. So I can see that this is exactly the same list that I saw using my dashboard. Looking into the S3, you can see that this is the same list as I have online. So you can see there is 8 different buckets. If I go to the Cloud API and I list buckets, maybe this time not as an XML, I can see that I see the exact same list but retrieved programmatically using Cloud API and RAD Studio. Okay, so that's quite easy. And now let's go back and see what it takes to extend Cloud API. We are going to see an example of extending the Cloud API to wrap access to the simple notification service. So actually this is a mistake on this slide. It's not S3 but SNS. It's an abbreviation for Simple Notification Service. So Simple Notification Service is a very interesting service where you can deliver messages to a number of different endpoints using different protocols like email, like SMS, but also mobile push notifications. So the key concept here is a topic. So you can programmatically or interactively create a topic. So this is a kind of a communication channel that you can send messages to, and then you can create subscriptions. So subscription is to the topic. When you create a subscription, you specify a topic, you specify a protocol, and you specify endpoint, which is different depending on a protocol. So in case, for example, of email, that will be just an email address. And then when you want to send messages, you need to publish the message to a certain topic, and all subscribers of a topic will immediately receive this message. So this is very powerful functionality, and we are going to see a custom extension of Amazon APIs. So very much like different existing Cloud API service classes are extending T-Amazon service and then T-Amazon basic service, we create a class T-Amazon SNS that is going to extend the functionality of a T-Amazon service and provide access to different methods provided by the simple notification service. In the demo, we are going to see how to programmatically build a request that can be sent to a service. Then we are going to see the functionality to list, to create and delete topics, and then list, create and delete subscriptions, and finally how to publish to a topic. Here we are at the Amazon Web Services console, and this is a home page of the Simple Notification Service. Here you can interactively create topics. So you can see that I have 6 different topics already created. I can see different subscriptions. So subscriptions are specific to a topic and they are using different protocols. So for example, I have a subscription to my topic, Paweł test topic, using email to the email address the delphidev@gmail.com. So when I publish to a topic, I could see this message delivered. So I'm going to actually build a wrapper to access this functionality. Maybe not the whole functionality provided by this SNS, but just to see what it takes to get started. So here is a test application let me list topics. So let me first start to show you what it does. So you have seen some of the topics that I had. So right now I can see that the same topics that I have seen on a web page, I can actually programmatically list. I can create a topic, so I can specify my CodeRage 10 topic, like this, and I can create it. So it was created. If I list topics, I see that my CodeRage X topic was created. I can go and delete some of the topics. For example, I can select this topic ARN, so this is like an identifier. Going to copy it, click on delete topic. I need to specify this as a parameter. Click on OK, and then I should see, if I list topics again, that this topic is gone. I can also list subscriptions, so I can, for example, list subscription by topic. So for example, I can specify my Paweł test topic as a topic that I'm interested in, and I can list subscriptions by topic, specify paste, and this is my topic does not start, I have somehow badly copied this, so again we should be more careful, like this. And then if I copy this, list subscriptions by topic, if I paste it here, click on OK, I should see the 2 subscriptions. And I can also publish 2 topics. So if I go to my gmail.com, I have created a dummy account, so the Delphi dev Gmail, and I have hello from Delphi, and I'm going to have more of those. So I'm going to publish and hello from CodeRage. That will be my CodeRage X, and I can click to the publish, and if I go to the list of my inbox, I should see in a moment that I have got this email, if everything works correctly. Maybe it will go to the social promotions. We can try one more time, because it looks like it was published correctly. Maybe I published to the wrong topic. Yeah, I need to do it on a Paweł test topic, because that's where my subscription exists. Click on publish, and I should see another message. Hello from CodeRage 10. Anytime I can unsubscribe of it. So this is a functionality that I managed to wrap. Let's have a look how it works. So the base, I have some classes here. The base class is AWS, the Amazon SNS. So this is a class that stands from the Amazon basic service, and this basic service provides me already with a certain functionality that I can reuse. So I can build query parameters. I need to override certain methods like getServiceVersion, getServiceHost. So these are virtual abstract methods that I need to override. So for example, let's have a look at the list topics. So we have here a reference to the documentation from Amazon, and I can go here and see, this is the list topics, and all those methods are actually nicely documented. And this is I need to build a request, the HTTP request, that has the following signature. So I need to specify an action list topics, and then this is a kind of a response that I'm going to get. It's an XML, and I'm going to get a list of just identifiers of all the topics that are in a given region. So like this base class that I'm descending from, make it easy to build all these things. So you need to actually provide an access key, you need to create a signature, and all those things are already there. So let's have a look, for example, how I'm doing ListTopics XML. So yeah, the result is the XML that was returned from the web service, and there is a query params, is a string list that I can call an inherited method build query parameters with a list topics as a parameter that I need to provide. And if you go here, you will see that this is already doing a lot of stuff for me. So it is building a number of different params that are passed to the HTTP request, and also you need to implement this get service version, because that's something that is called in my inherited class. So that's something I can have a look here very quickly. So get service version is a hard-coded string, and this is something I need to have. Also, there is a get service host, so I need to specify the HTTP the host. And then I can also build the full URL of where I want to send my HTTP request to. So it will take a get service host, and it will append it with the HTTP or HTTPS. So you need to really get used to HTTPS. On desktop client, the HTTP would work, but on a mobile client, typically you want to have an HTTPS. I provide some defaults for the protocol and for the region, but then this is something that you can change. But I want the class to be usable after it is created right away. And then we have this ListTopics XML. So we built queries, and if there are no optional parameters, we just take an URL and we call issue request. So this is another method that is inherited from the base class, and this wraps the whole functionality. So we can do a post or get request, and if you go into the, for example, issue this request, we can see how this is working. We can also see how the get request is being sent. So that's yeah, you can actually see for yourself how you can create this particular reference. So in starting from RAD Studio 10 Seattle, the Cloud HTTP client is based on the native HTTP library on each platform, so this is much easier to use. Before RAD Studio 10 Seattle, you had to provide different OpenSSL libraries in order to build your application. Now this is much more simplified, and this is very much it. So I can now issue a request, and I will get an XML response. But this is an XML response, so to make it a little bit easier programmatically, I also provide a ListTopics method without XML that will not return a raw XML, but it will actually parse the XML, and it will build SNS topics. So I have defined an SNS topic as a class, as an object list of SNS topic instances with ARN, and there is a name that is extracted from the RN. And similarly, I have a class for listing subscriptions, so I can easily encode subscription. So there is a method to create topic, to delete topic, to list subscriptions as an XML, or subscriptions using a convenient class. And also I have a possibility to subscribe, unsubscribe, and finally to publish to a given topic. So that's in very short my application. So I can actually send my I can list subscriptions, but also I can subscribe. So I can subscribe to different things. So for example, I have deployed to the cloud an HTTP server, and this is my other application. So you can send, I have not implemented the mobile push notifications, but there is a functionality to also subscribe by an arbitrary HTTP server. So I have created a web broker application. So it has a form receiver, and in this form receiver you can actually send arbitrary HTTP requests, but when Amazon wants to subscribe, it will send a special request, so the application needs to react and subscribe, confirm subscription, and then it's going to receive all the subscription, all the messages sent to a certain topic. So here I have a web module, so that's a typical thing for web broker applications, and I'm actually in the default handler, so this is a method that is invoked when any HTTP request arrives to the web server application. I have the process AWS SNS message, and this is where I'm going to actually parse it. So I want to typecast it into the specific INDI related message, so I can access it methods, and if I found the specific header type, the XAMZ SNS message type, then I know that this is a specifically for me. This is sent from SNS, and I can actually do some processing, so I can see if it is just a regular notification, or maybe this is subscription confirmation or unsubscribe confirmation. So there are three types of messages that I need to handle, and then I can actually do something with it. So on the main form I have a REST request and the REST client and REST response that I'm using to send a confirmation of the subscription. So that's how it works. Here is my code to send subscription confirmation. Actually it is currently hard coded here, so I need to stop the other application so you can see the properties. So here I have a REST request, and in the REST request parameter list I have this parameter. So this was done at design time for testing, but I can specify a certain options here, and I can send confirmation to the server that I want to receive confirmations. So in a different virtual machine, I'm going to switch to a different virtual machine very quickly. I have a virtual server running in the Amazon EC2 cloud, and this is a message that was received from my hello from CodeRage 2, because this application is already subscribed to receive any messages sent to this particular topic. So not only that it was sent to the email, but also to this application. Okay, so let's jump back to the slides. So in this presentation I wanted to show you how you can use and extend Amazon Web Services. With Amazon Web Services you can create very interesting solutions that can scale, that can be very reliable, that they can be redundant, and you don't need to build or provide your server-side infrastructure. You can just provision the exact number of resources that you want to use, and your application will scale and it will work great. So thank you very much for watching this episode, and I hope that you are going to enjoy the whole CodeRage 10 series of presentations. Thank you very much.
Okay, great. Thanks, Paweł, for that fantastic session on Amazon Cloud. It's great some of the things you can have Amazon Cloud take care of for you. Looks like you're online with us now for questions.
Yes, hi Jim.
Hello.
Here. So unfortunately it was quite long, so we are almost on the top of the hour. The first thing is that I have just posted on the community Embarcadero.com source code for all the demos. So if you want to play with this Cloud API and extending Cloud API, you can do it right away.
Okay, great. Are the cloud components, are those available in the professional version or are they available only in client server version?
Yeah, I've just looked into this question and verified in the feature matrix that it is also available for the professional version. So in both C++ Builder and the Delphi Professional, you can use Cloud API.
Okay, great. Can you quickly summarize the change to your SNS example to push your notification through SMS, i.e. text messaging versus email as you demonstrated?
Yeah, basically the process is that when you want to create a subscription, you need to specify a protocol, and different protocols will have different endpoints. So it's relatively easy for doing things like email, like HTTP or SMS. It's a little bit more more work to have push notifications, but this seems to be the most interesting option and something for me to work further. The biggest difficulty is to actually obtain programmatically the device token, because that's something you need to provide to the Amazon Web Services. It's a kind of a similar what we have seen 3 sessions before with Olaf session on parse, where SNS will store all the device tokens. And basically, when you want to send a mobile push notification from the programmatic perspective, it's the same. You just publish to the topic, but there must be some push notification subscriptions existing for any service. And what is interesting in SNS that is not only Google and Apple, but also the Baidu, the service that is available in China. In China, they don't have these other services available. So that's quite flexible, and I think is very interesting option.
Okay, great. So this is sort of related for building a Delphi application with cloud computing and MySQL. Can you point to any demos, learning resources, or any things to watch out for?
There is hardly any resources about it. It's a kind of an exotic topic. The first resources are demo applications that come with RAD Studio installation. So for number of releases, there is a Cloud Explorer demo that is a handy VCL application to play with a simple storage service. But now in RAD Studio 10, there is this other demo that I have demonstrated, and it actually shows how to work with all 3 supported services. So that's a good starting point to understand how to programmatically work with it.
Okay. And I'll paste this link here to your blog post in the chat window here for everybody. If you want to grab your code and more information, they can follow up with you there. All right. Well, fantastic, Paweł. This has been very educational, enlightening. Lots of great information in here to what we can do with the cloud.
Okay, thank you very much. Have a great time during this session. I'm really looking forward to some more interesting sessions that are coming.
Yes, it's going to be great. Lots of good stuff coming. All right. Thank you so much.
Okay, bye.
Bye.